Array index out of bounds. Hey, Coffee Compiler Club, trying to sort out like semantics of JavaScript, which I'm kind of thinking this is a bad plan. But everyone's being recorded. Will show up on YouTube in a few hours or whenever I get around to it. Yeah, good enough. So we were in the middle of a discussion of what evil things happen when you try to make a more optimized JavaScript engine. And Apo was trying to tell me what the semantics are. I missed how the semantics of indexing off the end of a string do something other than, throw a array index out of bounds exception. So go Apo.
Right. I'm actually gonna share this because it's can you enable
I
sharing?
can just a second. Da, da,
Because
da, da, da.
this is just
Try it
so
now.
unbelievably dumb.
Yeah, try it now.
Yeah. Share and how do I new virtual output? How do I do things?
We
Bots
have
is
a we
basically
have
now
an
see your
excellent
screen.
background screenshot.
Yeah, which is probably the wrong thing.
Like
Oh,
like do like the app instead of the whole screen.
yeah, yeah. My apologies. This was a bad choice. It also
Well,
managed to
didn't have anything not safe for work on your background at least.
no share. Why is it this too? Why is it so complicated here?
Exactly. There was a period of about 6 months where every time
Oh,
I fired up Zoom, the icon layout and how I found where to record and not record changed every time. They were adding new AI things and they wanted it in your face, except I didn't want any of the AI things. So it's a pain. Now I have a blank screen. I mean, I have a black screen.
oh, still not showing. That's okay. Then I'm just gonna explain. So
Oh,
okay,
put cut and paste into the doc,
right, right, yeah.
and I
So
will
imagine,
I will share the doc,
yeah.
and then it's not your fault. And explain as you go because we're like figuring things out
So
here. All right, I see you editing, so it's going to come in a lot
yeah.
quicker now. So it's all good.
So let's say you have a string in JavaScript, just a single little string. Um, JavaScript allows you to index into the string with
Right.
the expression member access. And this will, in this case, it will actually return the string itself because it's just the character A is the whole string.
So the A sub
And
0
then,
returns a string, not a character.
yeah, yeah, because there is no character type in JavaScript.
Fine.
Then if you index off the end, now you would expect this to return undefined because that's basically what JavaScript does. Like it doesn't usually throw errors at your
Right.
face. So,
Right.
you know,
Just yeah. Right. None is not a function or whatever. Yes.
but then if you do this, um, we go to the string prototype and define that one is to be
Oh no. Oh
or
no.
not to be.
No. Oh, you're kidding.
Now, when you do that, it actually does indeed return to be or not to be.
Oh my God. Oh my God. How do you
This
get
language is
anything
absolutely
done?
cursed. I have no idea. Like
Oh,
this came up with trying to do like cached lookups. Um, because in of course in JavaScript, in any dynamic language, you really need to be able to have efficient lookups. So if I like do A to uppercase,
yeah.
we need to be able to remember that, hey, this to uppercase property lookup on this string will actually return a property from the prototype,
Right.
and
Right.
then you'll be calling that. Um, but then, like, do we also hash this act or this like indexed access on the prototype and like gets
Yeah,
really, really
right. The
hairy.
lookup, like theory says the lookup tries the one. If that works, you're done. If it fails, somehow you decide it's now time to do an array like lookup.
Yeah.
Yes. So do you need help with suicide or, I mean,
No, thank you. I think I've got it well
got it
covered on
down?
my.
I was
Wow,
just
this is
poking
really
at
the
this in the
language
REPL.
semantics. Oh my
I
God.
was just poking at this in the REPL, and it's even more interesting because if you just display string.prototype, it gives you a map from the string one to the value that you put in. So it's not even uh, it's actually looking up a string version of the index.
Oh, it treats it as a string, which I
Yeah, yeah,
guess I
yeah. So
knew. I mean, I know it's like Python. All things with square brackets immediately do dictionary lookups. But I just didn't realize he did it on a string flavored, which I guess is straight up JavaScript. Oh God. Okay, so wait a second here. So I'd not paid any attention when we started. Let's claim 5 minutes after. I have no idea. Uh, wow. Okay, that's kind of
there's
depressing.
oh, yeah, it is. There is only one place where JavaScript has actually made the right choice with this kind of lookup, and that's the type arrays. There, they will actually like if you go beyond the edges of a typed array, it will always just return you undefined, as if this typed array had all other indexes defined as being undefined. It will not go
Yeah,
into the prototype lookup chain.
yeah, it's an
But
infinite.
arrays also do this, like where they will actually go into the prototype chain if you fall off the end.
Okay. Yeah, God, I've done this with some other languages. Elm was doing that for me. All lookups in Elm either returned optional if you ran off the end. There was no way to get an array index out of bounds or an undefined behavior, which meant that you had to endlessly check all things that you looked up or strip the optional off, even on things that were obviously, for I equals 0 to length of array. That was very suck coding experience. So I have an
It,
unrelated thing, only that Python has got some interesting design choices similar to, JavaScript here. So we're putting chained operators into simple. So we're going to allow expressions like this, and it just evaluates B once, but it acts, A less than B and B less than C. And you can mix directions as long as you don't change them. So this is also okay. Um, this is not okay. I wish Cameron were here. This is valid in Python, which I claim, the correct answer is if you really meant that, you should write this because specifically, because it just seems highly like you made a mistake. You really didn't mean that. And then we get to equals, and then I'm kind of like not sure where to go. So, so what do you do here? So without operator chaining, this is this style where you do two unrelated tests and and you try to see that they report the same thing. I use this kind of pattern, but generally not as a ranged on both sides. I want to know is this thing and this thing both equivalently true, but both the booleans are equal or unequal. It's a Zoring operator. And then, excuse me. And then the one where you don't is just saying I have a ranging operator. The first one of those, I have a ranging operator that I'm saying, A is less than B, B is in C or equal, C is less than D, and does that one make sense? It makes sense. Is it going to be used a lot? Like this first one where you have this range here, like in range test, that I can see a lot of uses for that. And I've certainly written things like that. So that one shows up in my head. The illegal one, it seems obviously just express yourself more clearly. But the equal one, I'm like, don't know. What do you want to do here? So Python will just say all operators can be chained, and they go left to right, making bools as they go. Well, they go left to right. This is a temp put into B is put into a temp. So A less than B, B goes into a temp, and the result of that B is then compared to C, which put into a temp, and then that's compared to D, and that all makes sense, and that all works for you go backwards like this. Except I don't like writing code like that. That looks ugly. And if I go to like Java, I believe C as well, operator precedence kicks in, you get this with and without the friends. And does anyone care? I'm going back and forth by saying it can be done, but should it be done? And this is where, where's Cameron? Because he's doing this in ecstasy. I wanted to hear his opinion. No one has an opinion.
But so what does Python do right now? Python treat
Allows this.
yeah.
It just makes each of the in between points into a temp, and it evaluates them in order until they fail. So it's like an and then you don't do more of the evaluations.
Yeah.
So the Python version, let's see here. No,
Yeah.
no.
Yeah, I'm wondering about Python for the one where the equals is there. I understand the
Yeah. So they say any operators, they're just going to, any of the equality ones, relationals, they're just going to go left or right. That's interesting. How am I going to, there we go.
hmm.
So, I call function zero and I say this, and I call function one and I go this, oops, whatever, and function two. And Python would say call function one, put the result in temp. Call function zero, put it in temp. Call function one, put it in temp, compare them.
Hmm.
If the compare is true, call function two, put in temp, and then compare the result from function one and function two, and so on and so forth. So you can have any count of mixed operators. It doesn't matter, whatever you want to do here. He'll just keep going until you fail the and.
Yeah.
I claim that
I'm
code
just gonna
looks
I'm gonna stick into the code block the output from the REPL. I don't know if that makes sense here.
from the Python
Uh,
REPL.
so I just in the Python REPL I use the AST library to like find out what it parses.
Oh, yeah. Somebody online was saying do the dump from the. I just
Yeah.
asked the REPL how to evaluate this, and this is, I got this thing.
Yeah, so this is yeah, I mean you can evaluate it and figure out what it's doing, but it's interesting to see what it's done. It actually has like this generic compare thing and it
Ah, yeah.
says here's the list of ops
Uh-huh.
and then what you're comparing. So yeah,
Yeah.
it's interesting.
Right. Now, is this interesting, but is this like reasonable? Does anyone want to do this for real? I claim this kind of
Seems
expression
very
nonsense where you mix directions is probably an error, and in any case, it needs to be clarified. And if you're going to clarify it, you would just rewrite it this way as a minimum, and maybe say, B is greater than this range, and B is greater than that range. And maybe you want to do a
You
min or a
could
max if A and C, B is greater than the max of A and C or whatever.
yeah.
you could
You know,
maybe argue that that okay, like mixing directions. Well,
yeah,
we decide that that is totally moronic. You're not allowed to do that. Then the equals case, you could then argue that actually equals is likewise a different direction than
yeah, yeah.
less
Yeah,
or
actually, that's not
greater.
a bad answer because there is this pattern, right, which I can see is
Yeah,
sort of reasonable to look at, right? Let me get rid of D here so we're not trying to do pairwise. So that one kind of looks okay.
And
yeah.
would you allow not equal to mix in there?
Then I would say not equals just goes to a different operator precedence level and it doesn't chain. I'm not doing chaining on like when did you expect that this meant something useful? What is the meaning here? Is C equal or unequal to A, or there is no relation?
I guess it just means unique.
Well, that okay. So you're claiming this does B is unequal to A, C is unequal to B, C is unequal to A.
Oh well, yeah, I don't know. I mean, I guess not. The first impulse is to say it's unique, but you're right that A and C have no relationship there.
Yeah, right. So then you repeat this pattern, and now you're saying I have 27 things that need to be confirmed all unequal to each other.
No, I don't think so.
That
Yeah.
that would that would actually be that would sound like it would be useful for like if that happened on somehow on the compiler level and was supported in the language, that you would then be able to use these like index into an array. I'm thinking Rust here, of course, that the compiler would understand like, hey, none of these indexes can be the same, so you're allowed to take mutable access with them.
Okay. I think we're stretching here. If you're looking for these things don't alias, so I can take mutable access in Rust, maybe you need an annotation that says, hey, and the compiler inserts the check, it confirms they're unequal at runtime, and you're okay. But I don't think that's generic language thing. Whereas this
Just
one
confirm
I
that.
have maybe used once or twice, like it happens, but it's just not common for me. These things are all known to be equal. Usually I know something and then I know the rest are all equal because I got here, but the derivation I got here by, as soon as A equals B, then also B equals C, and we're done. All right, I'm going back and forth on the equal equals, mixed in with the range operators.
Even with
Uh,
equal equals, it is a little bit ambiguous when you get to four items because then you're not sure if you're saying they're both equal or they're both not and they're both not equal, but they're not. It's like an
yeah,
XOR.
yeah,
Right.
yeah. Like this guy, you're talking about this guy here with the piles of unequals.
Well, but no, with the equals, if you had
Oh,
A, B, C, and D, then it's
oh,
like, well, are you saying A and B are have the same
yeah.
equality relationship as C and D?
Yes. So right. So the problem with this one is I have totally used this pattern before, and I'll put parens around so no one's confused. This is a pattern I have used before.
Yeah.
That's the Zoring like thing. It's related to Zoring, right? It's I want to know that the relation between these two things is the same somehow. So I'm okay with putting parens around and putting that guy that way, and just having a pile of equals in a row.
Yeah.
I would claim it's suspicious that I intend to mean A equals B equals C equals D they're all equal to each other. That seems less likely. And therefore I shouldn't parse it that way. And therefore I should throw you an error and say, go fucking add parens. Okay,
Yeah.
don't have to add the French in there, but yeah, add some parens here.
Yeah.
Clarify what you're meaning. Okay. So kind of in summary, we're on the same page on the mixed directions make no sense. Don't do it. And chained all in a row makes total sense and do it. And chained equals in a row is suspicious. We're not certain left or right. I'm inclined to say no. And chained unequals, just say no. Either well, not blow an error, but probably come up and say you probably need to put commas in here. Ambiguous parsing, add commas, or add parens. Sorry, not commas, parens. Add parens.
Yeah. With those chains of comparisons like that, usually if it's something sensible that you're doing, you probably want a function. So range or like between or you
You
know
know,
all equal or something.
there are places where you're doing weird things with doubly nested loops, and you're trying to do triangulation or whatever.
Right.
I'm not clear that it reasonably expects a function call here. Usually when I do the Zoring thing, it's not a function call. I'm trying to literally do a Zor, but Zors are hard to parse. It's a lot
Yeah.
easier in my head to say, I'm just going to throw an equal equals between two parenthized expressions,
Yeah.
parenthized Boolean expressions.
Yeah.
Yeah, I
When
can.
does when does something like the chaining of the not equals even come up?
Well, that was the question. So Python allows it because it's syntactically
Okay.
easy. The parser just does a dumbass thing. You're an operator. We'll just chain you along. Bang, 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 bang. Is that the semantics you want? I don't know. I have not used the unequals chained ever in my life. So when does it come up? Well, so far, never. And that means, when defining a language, maybe you shouldn't do anything here, or you should not allow, or you shouldn't make it surprising. No surprises. It's not what anyone expects to write, but if they do write it, no surprises. So I think Python's
Principle
behavior
of
in
least
my head is
surprise.
surprising, and I
I
would
think sometimes
claim,
the principle of least surprise is if you do
yes.
something really stupid, you should get a surprise. That's unsurprising.
Oh, I see. I wouldn't mind the compiler throwing an expression or an error saying ambiguous, wrap it in parens. It's like you're mixing ands and ors, and there is a precedence order on them in some languages and not in others. When do you want to say, when do you want the parser to say wrap parens? Okay, is this what I want? You know, when these A, B, C, and E are all big, long, hairy things themselves, and I've stacked this over 3 lines of an if statement, do I want to like let it go, or do I want to say add parens? And somebody comes along and says, "Oh, well, this is obvious," until they hit this thing where they said, "Well, actually, this was okay," and then I had to have another one here, and I meant to do it this way or something, right? It's just. So I've seen people claim as soon as you mix and ors, demand parens just to require
I'm in
clarity
that camp.
in order of evaluation. And I think for the unequals, I would also demand parens, the chained unequals.
I
Yeah,
like your rule of like same direction, but there's kind of an exception for the 3 unit less than or 3 unit greater than or greater than equal.
I'm sorry, like
Like those
this.
first two examples there,
Yeah,
it's like maximum length of 3. You're basically doing a between.
yeah,
It
you're in
gets more
between. Yeah.
confusing if you go to like length 5, I think.
Oh, yeah,
I don't
I
know.
think again, the least surprise. I claim it just should work, and no one writes the code. But if they did, it doesn't do anything shocking.
But you wouldn't just say uh
Chaining
that's an
limited to
error, you need
three.
parens. You have too many
I
things.
claim that if I do three, somebody will do four. This is
Hmm.
like I'm doing the bounding box. I have a hit box for my spaceship against your explosion thing on the wall or whatever. Things are going on. If I have three, I might have four. Okay, now that I have four, am I going to tell you no on five? That's surprising.
Yeah.
So I'm
Um,
in the zone of, whatever, 0, 1 many, right? There are no unicorns, there's one Earth, there's infinite stars. So we have an operator. Now we have several. Might as well go to infinite. If it wasn't one, go infinite. Go as many. Fine. Well, short topics.
There's a somewhat related remark, which I don't really know how to fact check since I don't have much experience with that remark. But I was listening to a podcast by these two NVIDIA engineers with like regarding like the loosey-goosey semantics of Python. And so one of the engineers was like, yeah, like, the future large language models are not going to be using Python to be writing whatever. And then the other engineer was like, actually, I think Python is great because of its loosey-goosey semantics. And they weren't talking about like Boolean expressions, but they were talking about object models. And so what the other engineer saying like Python was great for its loosey-goosey semantics is because since it's so loose, it makes it nice for like DSLs like Numba or like CuPy or
Right.
something like that.
That I mean, Python got where it is with the large language model with the AI thing because it allowed for easy exploration. Because it has this nice REPL and some obvious, we're going to try hard to make it go, which is what JavaScript does as well. Um, and that's also kind of, how you get big. You become accessible. You sit down at a REPL and you code. What does this do? What does this do? What does this do? And pretty soon you figure
Mhm.
out what it does. And then You can
I'd
start building
argue that
things.
it got there because yeah, it is user friendly, but it got NumPy, and NumPy became the de facto standard. And I've only ever seen pale imitations of NumPy. Every other language tries
Okay.
to like
But why did
build it.
NumPy go on to Python? I claim it's because Python was already there and NumPy just piled on.
Well,
Look at,
certainly Python had the extensibility to let NumPy work really well, but there are other languages that have that much or more extensibility and
did they
are
have it
also
in the
user
same era
friendly.
Python did?
What's that?
First mover advantage. They have it in the same era Python did.
Yeah, yeah. So like the other language I'm thinking of specifically is Ruby, which is was they were like on the same level more or less for a long time, and
But they're
then
very much later in life than Python.
Ruby's later than Python.
Yeah, showed up later. Yeah.
Okay, yeah, perhaps. Yeah,
Python is from the early 90s
Yeah. Yeah.
already. Started development. Anyway.
yeah, but Ruby is also from the 90s, maybe the
Can't
90s.
hardly be. Needs a JVM to be solid first. The JVM was just coming around then. I don't know that there are other languages on a JVM other than Java until somewhere in the 2000s.
Oh, Ruby's not a JVM
It's
language.
not a JVM language?
I
I've
think
only
you're
ever seen
thinking
it on a
because I
JVM
normally
because I
talk
guess I'm
about
talking to
Clojure.
people who do things with it on a JVM. Okay, fair enough.
Yeah,
All right, Ruby. Yeah, Ruby is also 1997. 1995, sorry. Oh,
yeah.
Well, it didn't
Um,
didn't win the
I thought it
war.
was.
it didn't win.
Yeah.
No, Ruby had the different killer app, which was the Rails. So
Yeah,
lots
Rails.
of web apps got built on Ruby,
Yeah.
and Python's web app thing. Anyway, it's sort of, I don't want to go into all that stuff, but yeah, they
Uh-huh.
had their strengths and weaknesses, but the scientific computing thing like really just like got super focused onto Python.
There is actually one mildly interesting possible reasoning for why Ruby lost, which would go for the accessibility. Um, Apparently, I don't particularly know, but apparently Ruby had a very kind of negative um, culture around it. Very very like put others down kind of thing, which doesn't really engender you to newcomers.
I haven't heard of that, but I don't know. I haven't looked at Ruby for more than a decade, and I just started looking at it a bit again lately. But
Ruby also had this interesting compiler technology that it's now merged into the main one, this YJIT, that is using a lazy compilation using a basic block versioning. There is more about it in that paper linked from that GitHub repository. But that's mostly based standalone. I think C-Ruby is the version used by Shopify.
yeah, there's actually two Rubies on the JVM as well. I just posted a link to the Truffle Ruby, which is on Graal only. It's got some special language server integration in Graal that they added, but it makes Ruby on the JVM more than 5 times faster than the other.
I wonder how was the interoperability because I think Python got really popular in the early days because it was so interoperable with C. So if you wanted
Yeah,
to quickly hack up some Linux script, you could really call the things like networking APIs just as easily as you would from C.
yeah, I think so. And the Ruby world had C extensions too, but they were more cumbersome, I think. It wasn't
Yeah.
quite as easy to deal with them.
Basic question about basic blocks. What is basic block versioning?
No, geez. Uh,
I I am by no means an expert, but I've looked into YJIT like very little. Basic idea is that you compile your code one basic block at a time based on what are your current inputs that you're going to be running. Like you compile it when you are about to run it, so it's a JIT. And at the moment where you're going to be running, you check your inputs, you compile it based on them. At the end of the basic block, you get kind of a new fork in the road. What basic block am I going to be running next, and what are my inputs now? And now the next time you come around, if you have the same kind of inputs, you're going to go the same route. But if you have different inputs, you're going to compile a new version of that same basic block, but with different types. And as a result, you kind of get this, like your function isn't jitted just once, it's jitted possibly many times for different optimizations or different input types. And yeah.
There is a bunch of links in this GitHub repository that is already in the GitHub in Google Docs. But if you go to this YJIT link, you have a very nice list of papers. And one of the first paper on that list is going to be simple and effective type check removal through lazy basic block versioning.
I'll put the
And
link in here.
the idea, the links you already put is when you put the GitHub, yeah, but it's all from that GitHub repository. And the idea is basically to remove the redundant type checks, especially if they're on critical path. Like if you have some for loop and inside that for loop you would be checking that something is of a given type. If you actually already know this dynamically, then you can compile a basic block with a version that doesn't check it but just assumes it.
Is there
There's a
oh,
nice
So
sorry,
in
go
the
ahead.
land of Hotspot, which does jitting at a different level, we certainly did all kinds of, I would say, specialization, um, which amounts to cloning basic blocks for known values that were not known statically, but known dynamically because you have profile data on the spot, you know something.
there's a nice tie-in back to JavaScript prototype lookup semantics and so on here because the author of YJIT is Maxime Chevalier-Bois, who wrote as her master's thesis and then PhD, I believe. She wrote a JavaScript JIT compiler called Higgs, which was also a basic block versioning JIT. And I believe they gave a presentation. This was something like 2014, 16, on the results that they got from Higgs, where one of the cited numbers that they gave was that they were able to remove 96 to 99% of all type checks from the compiled output.
Yeah. And that's Hotspot's experience with Java type checks. Something along that order of magnitude gets removed. Yeah.
Very cool. I'll have to check out the links. Thanks.
There are more links showing up now.
There's also a version of it's another research group on static basic block versioning, which adapts this technique to ahead of time compilation, and they implemented this for a Steam compiler, which pretty good results. They had reduced the number of dynamic type tests for something like half.
What was the compiler for?
Steam.
Okay. I hadn't heard that. Yeah, I'm reading your comment in the chat, but I mean it's just the summary, the abstract. Interesting. Yeah, I don't know. The hotspot JIT does method at a time and not trace at a time, but there are plenty of guys who do trace at a time or extended basic blocks, and they definitely version at the block header, knowing you came from a place where this was true, so you go to a block version where that's also true. The obvious one being JavaScript, and I have a small int for a bunch of things, and I want to know that I have small ints so I can take the optimal path. C2 would go ask the runtime what was something here, what is this thing, and if it's never failed or never gone bad or whatever, throw in the check and then clone the code afterwards for this fact is true. And if it never ever failed, then I might not even code the offside. So it would basically make you a specialized trace. Same kind of thing. specialization and it's just like another version of code cloning or inlining to get more knowledge about a specific thing. All right.
If one day I end up writing a JavaScript JIT, I think I will at least try the basic block versioning thing. Seems seems like it would be like the most beneficial choice.
For JavaScript, it might. I always liked the method at a time for at least for Java because you got more context before you fell into the hot loop. And that lets you put things that would specialize the loop better. And maybe it's, there is a difference in what issues have to be solved with specialization that makes the method at a time better for Java and not necessarily better for JavaScript.
Yeah, one thing that really kind of is a huge demerit of JavaScript generally is that it's so damn hard to prove that something in that loop isn't going to change the preconditions of the loop.
Yeah. Yeah.
Like every method access can always be a getter or a setter. And if it is, then it can do anything. So, or nearly anything anyway.
Right. Right. Yes. Somehow you have to bound your space of allowed changes so you can get away with optimizing something. Yes, I'm
Yeah.
not attempting to optimize JavaScript. And
You
maybe I'll
should.
be
I
doing
have a
some.
very interesting project for you right here. Come
Yeah.
on in.
All right, what else? I'm getting ready for Burning Man. It has nothing to do with compilers. We have an infinite supply of things to go do. I don't know if that's entertaining or not. I got my summer haircut. I got my annual haircut. You can all see my super hot weather haircut.
How long have you been going to Burning Man?
This will be my 13th or 14th year. So we
Has
kind of
any
have an expedition we set up. We go for 2 weeks at a shot. Take everything you need
nice.
for 2 weeks.
Does any technology conversations ever come up?
It happens, yeah.
Okay.
There are all kind of computer geeks that show up at Burning Man.
Does
Usually the
anyone talk to you
context
about?
is such you're not looking for each other, you don't find each other, but it definitely happens. There are compiler nerds at Burning Man that I have run into, and we have recognized each
Okay.
other and stopped and talked
Okay.
compilers.
Okay. Nice.
This is entertaining, but not necessarily a common expected thing. No. So yeah, new this year we bought a $1,000 uh, pickup truck that we're gonna take to Burning Man. Bright yellow, and we ran out of time. We were gonna do it up like a bumblebee, and we ran out of time. But it could be a lot easier to drive at least. We can fit everything in, be easier to drive than the giant cargo vans we've been taking. They're kind of a pain in the neck to deal with. All right.
Are, are you going to be keeping this, or it's a one-time use truck?
It's not in theory a one-time use truck. So we've taken it down, up and down the mountain several times to haul big things. I had a water softener fail, it was 25 years old, and it just gave up the ghost. Got a new water softener. We got another piece of artwork, which is a 4x8 sheet done as a photo op with this year it's going to be the Jetsons with George Jetson and wife and dog and everything else all painted up and set up for people to, put your face in the hole and get a picture taken.
That's cool.
We had like 5 trips with that truck hauling things up the hill that were, I guess we just pinned them for a while. I mean, suddenly it was easy. Go get the truck. New water softener came with, or it didn't come with, bought 4 sacks of 40 pounds of salt. So giant, couple 100 pounds of salt. What was the other? We had like 3 other big things that came up. Oh, Lisa's knee is still awaiting surgery. So she can't ride a bike. So we bought an e-bike. So
Oh,
that came up in the truck.
an e-bike
Uh,
is probably awesome up in the hills.
um, you mean, I'm sorry, the truck or the e-bike?
E-bike.
It's like kind of scary to be riding your bike on these hills.
Okay.
I see occasional people, but they're like young guys with, full combat gear on, trying to ride their bikes around.
Do you have to
No,
like
the,
hold on
the,
for your life when you go around a corner in case someone comes whipping around at full speed?
it's like the right. So everyone's aware that all corners are blind, but the hills are also really steep. So if you're on a bike and you're going downhill and you have to make a hard left turn that's completely blind, and on the other side up comes trundling, say, a Davis tree trimmer truck with a, chipper in tow, and he's filling the road. People in cars hit their brakes, truck hits their brakes, everyone stops and negotiates how to go around.
Yeah.
You cannot leave the road on your bike, and if you cannot stop in the same time frame, you're in trouble. Like you can't leave the road because you'll just fly down the mountain. You'll be
Right.
wrong,
Right.
wrong way to go out. It's no good. So
You better have good brakes. I've seen this race when people were professional bike riders were descending down the mountain and they were reaching like some crazy speed, like 70, 80 miles per hour.
right,
And
yeah,
you really need good reaction times and preferably closed
okay.
track so you don't have any cars.
But if you're 60 and you're riding a bike
Yeah, and
and
you
you're
have a
heading
car
down the mountain,
traffic.
you're
Uh,
not going to have the reflexes to manage that. So
Yeah.
I
You
don't
gotta
really
have
see people on
high
bikes around here.
high quality disc brakes and
Yes.
experience using it so you don't go throw yourself straight over the front.
Exactly. Now, as soon as we go down 10 minutes, we get to some flatter roads. There are plenty of bicycles. They
Oh
happen
yeah.
all the time. But up where we live right now, the first 10 minutes, I wouldn't ride a bike up here. And I don't see anyone else riding them. So,
Okay. I didn't
but
realize
yeah,
you were in such steep terrain there. I knew you were in the mountains, but
it's pretty crazy. And of course, giant potholes, whatever. But yeah, it's relatively steep and extremely zigzaggy for about 10 minutes.
uh
And then it kind of opens up and you get the one little mountain store and 10 minutes gets you on a freeway and 10 more minutes get you anywhere well, not anywhere, get you down the mountain into the Bay Area. And 10 more minutes get you anywhere in the Bay Area. So it's actually,
are you
reasonably
in the
accessible, but we plan our grocery trips
which direction does your slope face? Are you facing the
west.
water?
West. We're 2,700 feet and we can see the Pacific Ocean.
Oh, that's
It's
awesome.
12 miles as a crow flies to Santa Cruz. And then 40 miles across gets the other side of Monterey Bay, so we can see the other side of Monterey Bay. So we get enormous ocean views.
Oh, that's amazing.
It's quite. If you're ever in the Bay Area, come up and
I
have a
will.
wine or a beer on the deck and stare at the view.
Yeah.
It's pretty spectacular. All right, other compiler things? Anybody?
How's the simple project going?
I've stalled for modular.
Oh yeah.
So Tommy is still pounding out the chaining operators. He wants to do the OptoPass. I want him to do the OptoPass because I think it'll be a good learning experience for him. OptoPass should in theory, knock on plastic, be 20 lines of code. Um, so it's progressing slowly.
Okay. Yeah,
It's
I
like
how
still owe you like a review of all the readmes. I decided to start and just read all the readmes from scratch, but uh
you got busy.
then I got busy. Yeah, I've been I've been doing a lot of vibe coding, which has been an interesting experience.
Oh no, I guess I'll have to try that at some point in my life. I'm not there
Yeah.
yet.
Yeah, yeah.
Ugh.
No, it's bad and good in equal measure, I would say. So, um
are you really doing like vibe coding, like you don't even look at the code and only
no,
at
no,
the
no.
aha,
I'm
so
just
not like
saying it's
full
vibe
vibe
coding.
coding, right?
It's vibe coding compared to my normal level of coding, but just writing writing features into a web app and telling it, no, 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 move the button over here. No, move the button over there. No, move the button over there.
Ah.
And then eventually gets it kind of close. And learning about the tools like oh, you've got like you can drive the browser yourself and take a screenshot and look at the button for yourself. Now make sure it lines up properly. And then, oh, wait, that really works.
But why does he do that automatically? You have to tell him, take a picture.
Yeah, you kind of have to tell it. Like the
Fine.
stupid thing is, like I'm using Claude Code. It has such a tiny context window. I mean, let's face
Mm,
it, the whole thing is kind of amazing, but at the same time, imagine that you've got like a developer who's like an incredibly fast reader and you could just read your documentation at an
mm.
incredible rate. But like if you give him more than 10 pages, he forgets like the first page.
The first page. Yeah.
And
Interesting.
you have to like give him the right documentation and the task, and it all has to fit in 10 pages, and he'll zip through it and actually do it amazing. But if it takes more context than that, he can't do shit.
Interesting. Okay. Okay. Occasionally, I wonder how helpful he would be, Claude would be on like in compiler development, language development things. Like the less than equal relational chaining operators, in theory, should be a relatively straightforward hack on the logic of parsing the operators. You roll a while loop around. Right now it says go left, go right, read the operator, go left, read the operator, go right. No, you need a while loop now. Okay, you do. You need a directional. Oh, it's all less thans or it's all greater thans. Okay, it's not
Yeah.
too hard. Maybe.
I mean, I maybe I'll spend a bit of time like trying out how it works with simple and just see if I can add things, or maybe I'll see if I can get it to like supplement some documentation and stuff. We'll see. I'll play with it. But
Okay.
right now I'm messing around with other stuff.
I'll certainly take updates to the READMEs. Like, and then in the later chapters, there's all these fixes that went into the earlier chapters or coulda, woulda, shoulda. And so there's some point that says it's a tutorial, you do it this way. It's just a compiler we're building up from scratch, you do it that way. And think about how things are presented.
Yeah.
Yeah.
Yeah, I don't
I
know. There's definitely more in that project than it could ever handle in its context.
Oh,
But
in Claude, yeah, it could be.
but the crazy thing is that, you know, it's constantly improving. And so,
Yes,
you know,
exactly. And
just
a year from
imagine
now, all
in a
right, so I
few
have to
months
start
the
paying attention.
context will be better. And
yeah,
I,
what
I went through these funny transitions. Like I grew up and did computers with compilers before networking. And I watched the internet spring up around me. And I ignored it for a while because it seemed interesting and crazy and overly complicated and kind of stupid in a lot of ways. And then, email became a thing. And then a bunch of other things started to become a thing and became, oh, suddenly it went useful. World Wide Web popped in. Wow, there's some shit here. But I missed the first couple years to get my foot in the ground door on it because I was like, I'm busy doing compilers, leave me alone. So I probably should pay more attention this go around.
yeah, I feel the same
one
about Bitcoin.
one of
Yeah,
the oh sorry. One of the
oh, go ahead.
things
No, no,
that
no. Yeah.
one of the things that I think I was hearing like a lot of people talk within the AI circles as the next sort of big thing that they're hoping to provide unlock is like continual learning. So just having it learn online rather than like, um, having a cutoff for its data. Because right now, like even GPT-5 release, was it yesterday or the day before? It's like more incremental with the current paradigm. So.
Yeah.
Well, if the context remains, as you said, 10 pages and just a bigger context, be useful.
Yeah. I mean,
Certainly, I'm now enjoying the AI summaries like this one, right?
yeah.
These show up all the time now in the last 6 months, the year, and they've been generally helpful. So,
I feel like 10 pages is probably a bit of exaggeration. I think it actually can handle much more.
It,
Um,
yeah, I was gonna say that actually. You're right.
well, but the point is there's an interesting cutoff and you're hitting it.
Yeah, I hit it. And the thing is that it fills up the context pretty fast with its own thoughts. And if you have it do the wrong thing, like for instance, send it to a documentation site. Like I was using these controls, like UI controls, and the documentation site, every page is massive in terms of it's like here's 50 different ways you can use the control, and like fully enumerates them with examples and stuff. It's great for people. The AI loads one documentation page and it fills up half its context window, and it's like you kind of like have to like you have to think about it. You really have to think about your context limitations. As,
Yeah, it's sort of Gemini's context is so big, you kind of like play with the Claude, and then you put it in Gemini, the whole source repo, and you say
yeah.
take out all of Claude's bullshit comments. That usually helps.
New versions of Claude don't seem to add dumb comments everywhere, so that's nice.
From my limited understanding, I believe, and correct me if I'm wrong, but I believe the limitation to scale in the context is because the attention computation with the keys, queries, and values is quadratic. It's n squared. So there's a lot of research that is looking into attention variants that are sublinear. But then I faintly see some remarks in like the AI circles that like the sublinear attention variants aren't like panning out to just like the vanilla versions. But there's a lot of research
Yeah,
trying to
for
get
sure.
that
That's
down.
I'm pretty
Yeah,
sure that Gemini can do this huge attention windows because they build their own hardware, and the TPUs have somehow enabled something.
oh,
Because
interesting. Gemini
Gemini's
is
all
only
on
under
TPU. Everyone
TPUs,
else is using NVIDIA.
right?
TPUs, but also again, I don't know like the facts and like but JAX is ostensibly better for like distributed training and the whole TPU vertical stack as well over PyTorch.
Hmm.
Yeah.
All right.
Anyway,
Well,
I
I'm
feel
going to
like
be
I've
in
taken you
competition with
way off
PyTorch,
topic here.
but not with TPUs. Not in competition with TPUs.
What's
I am
that?
in competition now, I guess, with PyTorch.
Oh, right, yeah.
But not far enough along to say something meaningful about it. Well,
Is Mojo in competition with PyTorch?
kind of, yeah.
Okay.
And it's not where you're going to make money or lose money in that sense, but it's the modular business models more or less. We're going to make it easier to use all kinds of hardware, not just NVIDIA, or if you're Google TPU, or if you're Amazon, whatever there is, right? So the goal is to be useful to a broader audience across a broader set of hardware. And in that sense, it's trying to tackle PyTorch. Like PyTorch came out and said, "Hey, we're good for everybody on everything, except we're bad for everybody on everything in some ways. Some good, some bad, whatever. Isn't there a better way to do this?" Okay, there probably is. But if you're NVIDIA, you want people to use CUDA, and if you're, Google, you want people to use their TPUs, and if you're Amazon, if you're Apple, if you're whoever, you have your own private thing you want. But PyTorch was sort of like, I'm staying out of that war. I'm trying to tackle everything for everybody. And then question comes, is there a better way to do what PyTorch does? And that's what Modular is trying to do.
Because couldn't PyTorch be just rewritten actually in Mojo? Technically?
More or less that's what Mojo's doing. But PyTorch is this giant thing, and they've made some interesting trade-offs that make it difficult to move it in certain directions that make life a lot easier. So that is the rewrite, if you will, or that is a rewrite. Many people are doing the PyTorch rewrites because they don't want to deal with PyTorch and they want to lock you in on their hardware. So a PyTorch rewrite that is hardware agnostic. There's not too many of those. Basically, Mojo is looking to do that.
So is Mojo also looking to get into like the deep neural network like framework aspects of PyTorch, Jackson Friends, like
I,
neural networks, optimizers, data loaders?
I think Modular is trying to get into anything and everything to do with helping accelerate AI. Um, Whether or not that turns into different specific versions of AI models varies, but it's pretty clear that they're not trying to target a particular kind of model. They're trying to put a framework in place so that you can add a new model, change models. And the theory being is that the models are flipping rapidly. They are. There's the next one and the next and the next. So we're trying to do a generic framework for helping people build models and map them onto GPUs.
Very
How
cool.
what's your sense of how much parity there is between the competing GPUs right now? Like NVIDIA sets the benchmark, but uh, like I don't know if you've been looking at this stuff at all, but like how close are the AMD GPUs or other GPUs to actually um you know
Um,
yeah,
so the sort of the general rule is that the hardware is it's like the early days of microprocessors. The hardware is roughly kind of sort of equivalent within order magnitudes because it's the same underlying silicon, but people make sort of radically different design choices. And that leads to different ways you want to break a model apart so it would run better on different hardware.
yeah, but
So
are the AMD GPUs, for instance, really that different from the NVIDIA GPUs? This is something I've never
so
looked at.
yeah, I think AMD, I don't know. I think AMD and NVIDIA are closer to each other than say what Amazon's got or what TPUs look like. But
Yeah,
I'm
I
not
think
really certain. I've seen high level overview pictures of all these things. They all have certain things that looked fairly similar, other than the ratios and the numbers were all different. The thing that went on at Untether was more radically different than what I've seen from what other folks are doing with their hardware.
yeah.
So now, what's the right model to target? What compiler optimizations do you need to handle?
Yeah, well, that was a big problem for us that like the whole tech stack matured so much that it just became this insurmountable obstacle for us that,
Yeah,
basically we needed to be adapt to everything. And like, you've got 100,000 engineers working on different parts of tech stacks, and every part of all that stuff has to be different for us. And I think that
right.
was one of the things that was really one of our like that was probably our very biggest challenge. And then there was some other stuff.
So your hardware was not the only one of that flavor I've seen startups talk about.
Yeah, yeah, no. And I've seen startups that like got funding in the last year that have a similar hard architecture to us, but they're
Okay.
gonna have the same challenge. And I've
So
started thinking that the right answer is honestly just to like compile CUDA code directly to a different hardware and like basically.
you'll never beat NVIDIA at compiling CUDA code to different hardware.
But do you have to beat them? Can you just maintain near parity and
And
lower
well,
cost?
and then you're only price performance, you're only price, you're not performance.
Yeah, but price is pretty good in a business where the
Well,
margins are that big.
NVIDIA can just lower their price. It's a
Well,
I
standard problem if you're only competing on price and the
yeah,
entrenched part. This is a business problem, not a nothing but silicon at all.
yeah.
Yeah, you're
No,
only
I
competing on
agree.
price. There's an existing large person out there, large company. They have a giant pile of money and they're raking in money. They can totally lower their price for any amount of time and get away with it. And you'll run out of money,
Hmm.
right? They'll drive you out of business, and then the next generation chip will show up, and the prices will be right back to normal. And that is, happens in many, many monopolies across many, many businesses. Has nothing to do with NVIDIA.
But isn't
Okay,
isn't that basically wasn't that basically AMD's approach to Intel, and they actually did okay at that for two
they're
decades,
they're
and
the
now they took over.
they're the poor. They've been the poor child that basically Intel lets them live so they don't get slapped with being a monopoly.
Yeah,
They've been that way
I
for
mean,
20, 30 years.
yeah, but hey, it was a good business, and then when Intel made a misstep, then they just stepped into their place.
Well, I think they're not there yet, but maybe. But that's 30 years is a long time to run as a known you're just going to be in second place, and if you get out of second place, we'll slap you, and you'll be
to
right back down
I think something that
until
the
you.
closest thing for that is probably AMD heap. So AMD heap is very close programming model to CUDA, and they actually provide tool called Heapify, which can take CUDA code from NVIDIA and automatically translate this to the heap code that runs on AMD. And
Right.
the programming model is extremely similar. I mean, you also have the thread index, block dimension. I mean, you launch with the triple chevron or triple angle bracket when you launch your kernel. So if you are familiar with CUDA, it's almost one to one. Just
Yeah.
error handling is just slightly different, but it's that part can be, I think, translated.
So I claim
And
the Mojo model is a lot more generic and can support a lot more hardware more easily. And in that context, Mojo has a way to say, write it this way, and we can get you the good performance on CUDA-enabled NVIDIA hardware and on AMD and on Google and on Apple. So I think they've got a better answer.
I think those are, yeah, I think they're both good answers. And I think both need to be pursued. Yeah.
Well, people are certainly pursuing all the other options. So
Yeah.
we
I mean,
shall
everything
see.
is pursued, right? So,
yeah, AMD's strategy, like even like all the software libraries like Cutlass, Thrust, Kublas, they're just copying everything now. Like Nickel, they have Rickle, like anything with a prefix with N, just replace with R, and then they have now for RDNA, like their whole software ecosystem. But then going back to the AMD versus NVIDIA, like the business and like the price performance, like the enterprise level like GPUs are interesting because like the H100 versus the MI300X. From my understanding, the MI300X actually offered a better performance per watt or performance flop per watt or flop per dollar, but it was just fact that like Pytorch support, which is better now. And so I claim that all of the like machine learning accelerators that are not on the PyTorch, easily one click download are gonna have a trouble keeping up with NVIDIA.
This
yeah,
is what
that's
Modular is trying to do, make it just as easy to be one-click download, but
yeah.
you need to have your model rewritten. It's not PyTorch, it's Mojo. It's
Yeah.
type
I'm just
state.
waiting for the modular acquisition by NVIDIA, and then
Sorry.
I'm just waiting for the modular acquisition by
You
NVIDIA.
know, if I have some Modular stock and NVIDIA dumps $1 billion down, okay, fine.
Yeah. No, hey, I'm not saying it's a bad thing. It's a bad thing for all of us.
Here, Jim starting to chat. Took Claude 10 minutes. Ooh, to rewrite a model to Mac. Okay, yeah, and 15 to Gemini to verify it's legit. Okay. Okay, but 25 minutes to get a model up and verified doesn't seem like a bad amount of time. Actually, it seems
Yeah.
pretty.
And Jim, what if you do it in reverse? What if you get Gemini to write it and Claude to verify?
So now you gotta wait 25 minutes and find out.
So it's pretty versatile. It made MLIR and in like 2 minutes. Not that I tested that. Um, it bucked on going from MLIR back down to MLX, the Mac thing, and into Mac inference or whatever. ML core. So uh, usually, if you scare Claude, it'll just write comments saying, "Look, I'm done." And it didn't do that this time. But
You
that
have
was
to tell
before
you always
4.1.
have to tell Claude to think hard. Otherwise, it doesn't
Um,
think at all.
I use like a reward system, like if you can chain two functions together, you get like double points, and it actually helps a lot. If you say, "Yeah, no, we're going to be selecting the best of you to continue on,"
Right.
but yeah, so model conversion was, you know, I'm saying this before I test it, pretty quick or pretty straightforward.
I've always found that AI has been good for a while at porting code, if that's what you're doing there.
So I was porting a non backprop model, which still has backprop core ML isomorphs that it can use, but it's not written that way in Python the first time. So it's taken me a minute.
One
All right.
thing I found interesting, I just posted in the chat is
Throw the link in the doc.
oh yeah. I haven't looked too much into it, but this is Jason Ansel on the PyTorch team. He is experimenting with like a sort of Triton-esque DSL for writing kernels. And I think the seminar that he gave recently will be posted.
Hmm.
So yeah, the PyTorch team is also experimenting with different, I guess, semantic levels of the semantic gap.
And CUDA has this new programming model QTile, which also is another tile-based programming model. It's interesting.
Okay. Yeah, I don't know. It's a rapidly moving space for sure.
By the way, Cliff, did you have a chance to work with MLIR so already? You're
Well,
still
I've
onboarding?
seen it come around and I've read the or watched several, hey, this is what MLIR is about videos. Does that count as working with it?
I was curious about your thoughts and feedback, so to speak.
I think I'm going to hold off on answering that for till I've messed around with anger with it.
All right, fair enough. I can throw
I'm
some more links at you if you want. There is a very good tutorial by Jeremy Kuhn. He's written this for his team as well. They were all onboarding in MLIR.
Yeah, sure. I mean, I'm in the zone of watch all the videos and learn all the things, so that's where I'm at. I'm
I
consuming so many videos a
posted
day.
this in the chat. I can post this on Google Docs, but it's probably
Yeah, if it's all public, then throw it in Google Docs.
Oh, this looks good. I'm gonna look at this too.
yeah,
I
it's
really want to get Cliff's thoughts once he's sort of fully ingested MLIR
yeah, me too.
on uh, Sea of Nodes version of this, because I still think that this should be in the Sea of Nodes, and it's like it's like the planet of nodes.
Um,
Well, that or
Could be
how
wrong.
viable would be to encode the semantics of C of nodes using MLIR as a representation substrate. So don't really use MLIR with any of the upstream dialects, but if you were to design your own dialect, can you give it semantics that would correspond to C of node? And what would be the cost benefits of doing that? I
well,
would be curious
right.
about it.
So yeah, I need to go further in. What I've seen so far, it doesn't. What I've seen so far looks like a lot of ceremony and decorators wrapped around something very similar to what I'm doing, but a lot more ceremony. I'm
Yeah,
not seeing. I'm not seeing the payout other than I just wrote some code and threw it in an IR, and it's all use def dependencies anyhow. But it's not
yeah.
time for me to make that judgment. So it's
My
time to
thinking is
dive in some
really
more.
that it's like flipped the other way around to say the concepts of doing high level transformations at a conceptual level, at a domain level,
Yeah.
in a graph that then folds its way down, lowers its way down until you actually have program code. And then that program code is already in Sea of Nodes, and then you just keep on compiling. But the difference is that maybe you end up with multiple programs, or you end up with like, I don't know.
There's certainly no reason to assume a node in the sea of nodes doesn't encode a high level operation like a matrix
Yeah,
multiply. That,
exactly.
that would be a normal thing.
Yeah. Yeah, exactly. It seems totally normal. And it's just like, I think the challenge is trying to like understand the bounds of, like, for instance, does it work to use the normal um uh work list when you've got super high level nodes that explode into eventually all sorts of things,
Yeah.
uh
So
and then it's
so
like mixed in with low level stuff, and
right.
then maybe some optimizations happen in the wrong order because of that.
Right. So that one I've already been beating on for a while with the simple project. So I've got the simple project where it's got I'm going to say called it's a variation of the one-step church roster property. So it doesn't matter what order operations happen, you get the same answer out in the end.
Yeah, does that work when you're dealing with such high level? Like, can you maintain that property with
Yeah, right.
such
So,
high level
so
nodes?
a goal is to maintain it. Now, so ignoring the high level, low level, just put in function calls with inlining. as soon as I say I have function calls with inlining, I can certainly arrive at a spot where order of inlining matters because I'm not going to maximally inline everything,
Yeah.
right? A calls B calls C. Well, one answer is A inlines B, B inlines C, and I can go those in either order because in the end, they're both going to get inline and the semantics are a flat program. But suppose the sizes are such that I can't afford to inline both A into B and B into C. I have to pick one or the other. And now it makes a difference as to how you pick them. And so as soon as you recognize that it makes a difference, there's an ordering that makes a difference. You have to figure out what the order is you're going to go after. So on these high level things to low level things, the easy one is the mix of the high and the low in the same graph is easy. That just happens. But now when do I explode a high level to a low level? It's more or less when do I inline it and give you the low representation from the high level point of view? Well, it's when I'm done doing things at the high level that I would have trouble recognizing and doing at the low level. And so when does that happen? Well, somebody comes along and says, I have several matrix multiplies all in a row, and I want to resort them so that you get the minimal dimensions at the inner loops, and I want to make two transposes cancel on whatever things are going on. Then I come along and say, I have these several kernels that are doing funny things in the inner loops, and I want to fuse them or not, or whatever. As soon as you come to a point where you make a decision that typically takes a simple guy and explodes it, and then I can't do things easily on the original simple guy, you have an ordering problem. And now you have to recognize you have an ordering problem and figure out what the hell it means.
Yeah, but so for instance, what if you have a multiple levels? So like you've got, say, a couple of matrix operations, and they're all lined up nicely, and you could do something nice on them.
Yeah.
And then, but there's also some, like at one end, before, say, right before you hit those, you've got some mystery op, which is like even higher level, and you could conceivably do something with those two matrix operations, but maybe the mystery op then turns into a pile of more matrix operations later, and you actually
Right.
you're better off waiting for that op.
Yeah. What you just said was I have an order of things I need to decide what I'm going to explode or not.
Yeah.
And I don't have an answer for who picks that. Right. So the current sea of nodes theory is that the only one of those I hit right now is I have inlining or not. And
Yeah.
I'm going to pick an order that makes reasonable sense in all cases and say, that's the order and we're done. But there could be a different order of the inlining that works out better,
Hmm.
only because you can't explode them all. The safe fix is you just inline maximally and you're done, and then everyone can do everything, and they have to be able to recognize how they do things. And that's exactly what your matrix multiply game is playing is
Yeah.
once I've exploded, I no longer have easy access to whatever XYZ.
Yeah.
So
Yeah.
yeah, there is a ordering problem. I don't claim that MLIR solves it, and I don't claim that I solve it. I've
Yeah.
seen MLIR talk about it, and I'm talking about it too, but I don't
Is
have.
there a is there I think the one thing that seems to solve it with the addition of a huge overhead is egraphs, and because they do all combinations.
Yes,
And they're
yes,
very see it like what's interesting to me is that the egraph representations I saw aren't quite as good as the sea of nodes representation, but I couldn't see based on my minimal looking into egraphs and the fact that I looked at them when I was really early at sea of nodes. I never could see why egraphs couldn't be in the sea of nodes representation, and that would just level them up. Because there's some tools, and the people who did egraphs certainly didn't know sea of nodes. Um, and for high level transformations, maybe something like egraphs is the answer. But then for once you get to low level, I think you want to switch over to a Church-Rosser property thing and forget the egraphs. So maybe there's some like hybrid solution there. That's kind of my first thought on
So,
that.
so the thing with the Church-Rosser, one-step Church-Rosser properties is basically it says it doesn't matter what order I do things, I'm going to get to the same form in the end. That also means I can do a dumb work list, and I guarantee you sort of the optimal. There will be a fixed point. You're going to hit a fixed point. The thing with these high-level transformers is the state space you're exploring is too large. So define for me what the fixed point is when you're going to get to at the end. There should be, should be some way to optimally define what it means to be the best. And that's the fixed point you want to hit to. And then that means I'm going to apply these things in some order and I'm going to arrive at this fixed point. If you can't define that, you can't, then I don't have an algorithm that solves this. It's the same as every problem, every numerical solver for every kind of, gradient descent versus, generalized linear logic or whatever. All these things have this problem that they're exploring an n-dimensional space. There are local minima and local maxima. They get stuck in the locals and they can't get past it. And so they do, simulating and annealing and all these things. These are all sort of tricks to help you not get stuck in a local maxima, but you can totally get stuck. All right, that's going to happen here as well because the exploration space is too large. So then you go from I have an exact answer to I have an approximate, and what are the 1,000 different ways people get a better approximate answer? Okay, while I don't have to do the approximate one, while I'm doing the one-step Church-Rosser all the way, I get the perfect answer every time. As soon as I get to these things which have too many states to explore, I don't know how to get to the perfect. Now we have an open season on pick your heuristics. Do all the high level things that say they want to do from some do declare an order on high to low. The high level guys get first pick until they run out of things to do. Then you explode them in the next level down, and then you go again. Something, pick your heuristic.
Yeah.
Ultimately, we're exploring an infinite space of state space transformations, trying to get
Yeah.
an IR that represents some perfect, better
Yeah.
world.
My understanding is that MLIR's solution is pretty simple, and you just basically have a pass list, and you just go through them in order. Pass
Yeah,
by.
yeah. And I would claim that I wouldn't do it that way. I would instead say the operators are given levels, and people with a higher level go first. And when you run out of the higher level things, you do lower level things. And at
Yeah,
some point, the high level guys explode out.
which is basically what the I don't think Simple has it, but my compiler had the like multiple work lists.
Oh,
Right.
yeah, AA did the multiple work list too, but that
Yeah.
was purely for performance. I had no change in how the answers went.
But
Like
that
the things,
did
dead code,
force, no, that, well, you had the church one-step Church-Rosser property in action, so then there was no change, but it does actually force the low level, like the stuff from the first work list to happen first.
yeah, yeah.
So it does force an ordering.
It does produce an ordering. The goal of that ordering is to improve the compile speed. It is not to change how the in program shows up.
Yeah,
So
but isn't the,
dead code gets deleted first. Don't
yeah,
optimize dead code. Okay, that's an easy one.
yeah. But that like has the same effect, and you can use it for the that like the ordering characteristic, I think.
You give up on Church-Rosser and say, okay, I don't know, so it's not going to be perfect. Now,
Yeah,
because it's not perfect, there are choices to be made, and on some programs you'll get a better answer, and some you'll get a worse. It's
yeah,
heuristic. You always get better or worse accordingly. And that's
yeah,
okay. Just admit it. Okay. And now I don't have an argument that says that your solution is better than mine.
yeah. No, I wouldn't claim to have any solutions yet.
Yeah. And so in the theme of what I do with Sea of Nodes, I would go through and say, I'm going to do all the things that I know I can do that won't hurt anything. So anything that has like Church-Rosser like behaviors, I'll just do them all because nothing will change out of that. You'll get the same answer. Okay, done. Now I'm settled down with a bunch of high-level nodes and a bunch of low-level nodes, and I want to go to the high-level guys and say, do what you're going to do. And then, when you're done, you should drop a level. And then I'll run the Church-Rosser things to a fixed point again. And then I'll come back around to the next highest level guy. It's the same kind of thing we do with like an inlining heuristic. Do all the Church-Rosser things. Oh, okay, they all get the same answer. Okay, done. Now I come back around. I have 27 things I can inline. Which one goes first?
Yeah, and maybe in that world, the inlining is a lowering level in the same spirit as other
Yeah,
high
it's a
level.
lowering level. Absolutely. Yeah. So I have A called B, B calls C. Well, if A calls B in a loop, I probably want to inline B into A. B calls C in a loop, I probably want to inline, C and B. If they both A calls B calls C all in a loop, but I can only inline one of the two, I'll probably go to the innermost one.
Yeah,
There's a set of rules I pick. Somebody goes first. So
yeah.
there's a heuristic
Well,
that says do them in this
what
order.
Yeah, one of the things that was also mystifying me about MLIR was I couldn't answer to myself whether the high-level nodes in MLIR are really just function calls with broader flexibility in terms of their usage.
I think they're allowed to maintain more state. So let's pretend they have like a function call, but the function knows he's going to iterate over a state space over his inputs. He's got some arrays kind of input, and he's going to iterate over the state space, iterate over the arrays. Okay, he's
Right.
going to iterate over maybe in some order or not, but he knows he's going to walk over this chunk of memory. The next
Right.
operator has the same knowledge.
It's like you have function calls, but you know a lot about the
Yeah,
function.
you know more about him. Yeah.
Yeah. Yeah, that
And
makes
then
sense.
two adjacent
You
matrix
really
multiply operators can now
and
say,
you really have semantic meaning. Like you can have a dialect called SCF, that's structured control flow, right? And in that dialect you have operation like SCF4, which corresponds to a for loop. What you can do with this for loop, you can, for example, throw a transform dialect unroll, which is going to unroll it by a given factor. You couldn't generally do this if you only had lower unstructured control flow dialect. Like there is a lower level dialect called CF, which is very similar to LLVM IR because it only has labels and it has branches to those labels, which is really just like low level control flow. This you don't have loops on that, so you cannot do just unroll a loop because there is no concept of a loop. But with the SCF, you can do quite a lot of things. You can even there's also for lineage. Lineage, it's inspired. The name is inspired by linear algebra, but it's really perfectly nested loops. So you only have operations in the innermost loop body, and this, for example, you can tile.
right.
So if you can tile this 2 by 2 or 16 by 16, and again, this would be really hard to do on the unstructured low-level control flow dialect like CF or LLVMIR.
So when C2 sees a Java program and it has all the low-level things, it doesn't have the loops, he builds up loop structures. And I eventually get to the point where I have affine counted loops, a nested series of affine counted loops I can do things with. Is that a dialect change? I don't know. What does it mean to be a dialect? It's the
Not really.
MLIR dialects have a thing with them, and I'm not clear that it's like a super what the usefulness of the dialect
Dialect,
gets
dialect is
percent.
really just the name of an IR. It's a domain-specific IR,
Yeah.
and the point is that you know that it preserves those invariants. So this reverse engineering you mentioned, or lifting the semantics from low-level dialect, this is also what is done in LLVM-based compilers. When you try to recognize the loop, and then you
Yeah.
may have to put it in canonical form to be recognizable, and on and on. The problem with that, it's not only it's pretty expensive operation, especially in LLVM IR, it actually is 10
Not
times. In LLVM it's this unrolling example I gave. It can take 10 times more to compile. So when people complain why LLVM is so slow, well, because it often has to reverse engineer high-level semantics from low-level details. And that
okay. So
actually is very, very costly. And remember, you don't do this in C2 because you don't really do have advanced optimizations in JVM, like advanced loop tiling or
okay. So
loop
I
fusion
reverse
or
to get
loop
the
fission.
loops. So I reverse from non-loops to get loops. That's not super expensive in C2. I now could tile, but I have to get some help from the GC to not screw up two-dimensional, multi-dimensional arrays.
Right,
I
right, right.
definitely do things like unroll and jam, and they're not super expensive. That
Yeah,
that's
I
a
don't.
different issue. But let's claim
Yeah,
the implementation costs are an unrelated issue. There is the design. Certainly, if I was handed array shapes loops from the beginning, I wouldn't lose them,
right, right.
and then
In
I wouldn't have to go
LLVM,
discover them.
the problem is that you often have to put them back in canonical form after you have changed something. Like so if you have some loop optimization paths, the problem is you want to maintain the invariant that this low-level soup of control flow is still a loop. So maybe you have reordered loop, maybe you have fused them, maybe you have tiled them, maybe you have parallelized them, maybe you have vectorized them, maybe you have rotated them. Every single transformation in LLVM like that, many of them have to rerun the loop
Oh,
canonicalization process to once again recover or at least verify
oh, I
that the
see.
loop structure is still understood.
Yeah,
This
I
is the
don't do
problem and this
that.
is costly
I don't
because
lose that information if I restructure.
Yeah, so in LLVM you could or you have to pay some costs to maintain this in the transformation passes themselves. You have to think about how to write this transformation passes so the loop structure is still preserved. Whereas if you have something like MLIR dialect, SCF4 is going to mirror SCF4. You can
Okay.
reorder this, you can fuse
So
it,
in
you can change the
C2,
operation.
I have a node that says this is an affine counted loop. And it's the
Yeah,
same, extends the normal non-affine loop, extends a region merge point, which is a low-level node. But the high-level guy says, I know I'm an affine counted loop.
yeah, and it stays to be an affine
And
loop.
it stays that way. Yeah. And I unroll and I rotate and I loop and jam and blah, blah, blah. And he keeps that node. Yeah. So I
So
don't lose it.
this is something that is lacking in LLVM IR at least, because it
Yeah.
really doesn't have that good of a representation of what loop is.
Okay, fine.
And it's
Yeah.
not enough. I mean, it's not enough if it was just surviving in the internal state of the compiler. So it's fine. You could write a compiler that knows how data structure that has some flag that says, oh, it's an affine loop, right? That's not sufficient because remember, LLVMIR is something that has to be modular and composable. You are supposed to interrupt the compilation at any point, dump this to a file, then put this file to another computer. Another computer has to load this LLVMIR and it has to resume the compilation and optimization. So if you don't have that, the problem is much simpler because you probably can have some just internal site table or data structure in the compiler that remembers that the loop was affine. But in LLVMIR, the loop is affine. This has to be a direct construct
So
that
in
it survives in the IR with IR understood as a language.
so in C2, it's just a normal loop node. It's the affine version of a loop node. And the affine indices that are running around are found also as normal nodes. It's just a phi node that's the loop index that trips, except he already knows that the trip is based on a lower bound, upper bound stride and things like that. And then if I were to dump that to a file and load it back in, it wouldn't be any big deal. It would be
Right, so
like
you
just
basically you have an operation. If you treat this as a language, you would have an operation that says this is an affine loop node, as opposed to says this is just a loop node.
that's correct.
Yeah,
It's
yeah.
just
See,
a C++, is it C++ class, right? So there's a region,
yeah,
which is merge any two control flows. There's a loop, which only has two inputs. There's a fall in, and then there's a backwards control flow, and I know that's a loop bounds. And then there's the counted loop version of the same guy who, in addition, says there is an induction variable. I can find it by going to the back edge and looking at the exit test. So
right.
it's two or three pointer hops to go find the exit test. That tells me what the induction variable is that the loop's
So
primarily
essentially,
executing
it's
on.
it's possible to say that you in a fashion you already have a multi-level IR
It
because you
is.
are able to represent multiple semantics level in one IR, whereas
I
LLVM
am.
IR is
Yep.
not really that. So
I
that
Oh,
kind of
am.
could be the
for
difference.
Java, you have to do that. Like, I'm sure there are many other aspects that get lowered through C2 representation.
I'm sorry. C2 certainly lowers at some point. What are you saying again? Say it again. I missed.
Oh, I'm saying that C2 definitely has multi-level IR, like
Yeah.
in one form or another,
Yeah.
because in order to do any kind of decent job for Java code, you need to optimize at both high and low
Oh.
level.
There's mostly it's not. The loopy guy is in that sense, if because we're calling it high level. But like I just get a wad of bytecodes and I
Well,
run.
I'm thinking more of I don't know. You probably have type check at first as a high level operation, but then at some point you want to lower it to the like loads and store to loads and checks that it has and optimize across them.
Oh, okay. So there's a handful of guys that explode out into machine code, and they're generally done as templates. The register allocations allowed, but the templates maybe a couple instructions. But there's actually not very many of those. Like memcopy gets inline for one of those, but like the type check, that is exploded into normal IR ops that do the general type check in the parser, which almost always optimizes down to a load compare branch, and I don't call it or treat it any differently. But because it has a load compare branch and then it has the upcast on the different arms, you get the stronger typing, and it is a fully
Oh,
exploited
okay.
type check with total knowledge, if that makes sense.
But yeah, and I think for each of them, you have this choice whether to try and optimize it at a lower level, or keep it as a high-level operation and have a high-level check.
For safety checks in Java, I always went down the path of exploded them all the way down and also kept sort of perfect knowledge through the types such that I could totally tell you that this was a type check of some kind or another. But the reason I dropped them like that was so that I could immediately find all sorts of partial redundancies among half type checks. Like half of a type check can be totally optimized, but somebody else's other half type check and cleaned out. That gives I still have the one-step Church-Rosser property for type checks. So I don't care what order they happen. They happen in any order everywhere, and it's all guaranteed the same good answer. Inlining, I don't have that property. Loop unrolling, I don't.
Basically, you have this choice of how to represent something for like many different operations. You can have this choice for loops. You can have this choice for type checks, array copy, or whatnot. And yeah, different implementations just choose differently. There are pros and cons for both. I
guess I'm saying
straight away.
For some of them, I've recognized that I get to the one-step Church-Rosser place, and then I don't care. The low or high level is immaterial. You'll get the same answer every time anyway. Might as well drop it now. You're going to drop it later. You're going to drop it at some point. Doesn't matter. Whereas things, especially things that replicate code, like loop unrolling, I can't make that guarantee. So a stupid example is one of the stupid early benchmarks did Zoring of things in a loop. But after you unrolled it twice, the Zor is canceled and became identity function and the loop collapsed, disappeared. Whereas if you unrolled by a factor of 3, you'd be right back to where you're still Zoring and you wouldn't collapse. So there is a change of the amount of unrolling that would make this huge difference. The loop completely disappears or you have a loop based on the amount of unrolling. And that one I didn't have like an obvious one-step Church-Rosser solution for. There's a heuristic. Hey, we got stupid Zor in a loop. Unroll twice and be done. But that was a heuristic. Like, I'm not going to take Fibonacci and go to the closed form Fibonacci in the loop unroller.
So I have another example, which is Java specific. So boxing and unboxing operations.
Yeah.
You can either represent them as specific boxing unboxing nodes in your OIR.
Yeah.
That's what T2 does. Or you can inline it and then try to optimize it in the inline representation, just recognizing that, okay, you have an allocation on one side, you have load from the cache on the other side, etc.
At Azul, I tried hard to make that guy have that Church-Rosser property, and I kind of bounced my head on the 128 element cache. And I may have put in a special hack to recognize that specific caching thing, and that would get me back to the one-step Church-Rosser property. But it wasn't.
T2 today has a dedicated node for this.
Okay, it may now, and it may at Sun. It didn't when I left Sun, it did not, and when I was at Azul, it did not.
Yeah, in Falcon, we first did it by inlining and then recognizing the inline representation. It happens to be very fragile, so I actually introduced a dedicated boxing.
Yeah, that makes sense. Like I said, I got to where I had the one-step Church-Rosser, and then I didn't care if I inlined or I didn't, but I put in a special hack for it, which was didn't feel happy either way. I could be totally talked into putting a box node in for that guy.
Yeah, we didn't need the unbox because unbox is just a load, but for boxing, because it has this weird diamond and the cache.
It has the cache and the diamond, right? It's weird. Yeah, exactly.
And as for like LLVM and loop representation, like in theory, LLVM could introduce the natural loop as an IR structure, and I think there were some kind of discussions about it. So it's not.
There were like several attempts over the years. I remember that just never really got in the upstream. I think the thing is that maintaining this representation as you go along the passes could still be brittle, and
that's kind of like weird because for me maintaining it costs nothing. It's just
maybe you just don't do invasive enough loop optimizations, because I don't really think that JVM has that many loop transformations.
So I'll roll. Well, okay, it's fair because of the.
I mean, tiling, fusion, fission. They can really rewrite what the structure of the loop is.
Fusion and fission are there, but only for limited cases because the performance isn't expected on those places. Unroll and jam are there.
And
Rotation
the
to get back.
vectorization, of course.
I'm sorry.
Vectorization.
And then unroll to enable vectorization for SIMDiops is there.
And do you do vectorization too, or
So yeah,
what's the phase ordering?
if you have the right shape of loop, so the heuristics are there, he'll arrange the unroll so that you'll get a pile of things that are now candidates for SIMDiops or vectorization. And then he'll go ahead and match them up and say, okay, here's a pile of SIMDiops. That happens. That was there when I left. That was the early SSE ops. I was doing that when I left. So not tiling, not blocking, but yes, vectorization. And of course,
It would be interesting to understand what are the differences that make it easier to preserve it in one shape, in one form, but not the other.
yeah, I don't understand, right? I don't understand how you lose it, but this is a whole, this is a we can't we're talking we're
Well, LLVM
completely
has this canonical form of loop. I can see if I can find the dots on this, that it has to be in a certain rotated shape.
okay.
And you can lose that even if you move the basic block around a little
Well,
bit.
I got no basic blocks, so maybe there's a thing.
Maybe.
During the loop ops where you clone code, I will build up a loop body and make a clone of the body and then patch it in. But then, the head remains the same. The header remains the same. It's still kind of loop header. It still tells me where to find the upper bound, lower bound stride, the induction variable and all that. That didn't change because I unrolled.
In LLVM, so I posted this link to canonical loops, and basically you have this loop rotation pass, and really the role of the loop rotation is pass is to put the loop in a canonical recognizable shape. So now that the other passes like loop invariant code motion can just operate assuming that shape.
I see.
So that
So for me, loop invariant code motion happens because I throw away the thing, throw away the basic blocks. But when I do a loop body thing, I do have to rediscover what's in the body. So I don't do a loop invariant code motion. I do a discover the body, which automatically throws out of the loop anything that's not in the loop. It's a little different take on how to do that. And the actual loop invariant code motion happens at scheduling of C2, which is way down the line, whatever.
that is
My global
different.
scheduling pass does that piece
Interesting.
far later in life.
Well, someone has to implement the C of nodes style in MLIR framework just to see what benefits come from what, like what benefits come from just the C of nodes connection versus what benefits come from the different framework.
Yeah, exactly. That's what's staring me in the face right now. And I need to understand enough MLIR to make a reasonable call what the hell to do here. So I'm
Well,
off in the land of watching every MLIR video on the planet. Yeah.
I think this is a this is gonna be a good recurring thought or topic for each week.
It could be, but I don't have enough to say a whole lot now other than I know what I do in C2 and I hear what happens with LLVM and I'm like, how did you lose that info? And they're like, how did you keep it? It's okay.
One question I had for you, Cliff, which I'm sure a lot of people also have in mind, is like when joining a new job in general, but more specifically for like compiler positions, how do you navigate that, transition where like let's say you're the C of Node, C2 guy, and then like you're learning all this LVM, MLIR, like how do you communicate that with like the team or your manager? Uh,
Well, this is a first transition into anything with MLIR, LLVM for me. I
right.
watched LLVM grow up and get giant and piggy and huge, and I was like, I'm not touching that thing. So I stayed away from it for 20 years. So you're asking a question. The answer is I had not done this before. When I
Okay.
left Sun for Azul, I was just a sideways shift for as far as I was concerned. I have a new management team. I have the same JVM. I got new hardware coming. I'm going to do a funny port to new hardware. I'm going to add some new features. Sideways shift. I left that for a startup. I was, co-founder. It was not a compiler-based startup. I had my compiler tech. I also had all distributed scale-out runtime things I was doing. I used my compiler tech to good use, but I was not a compiler writer per se in that job. That was H2O. Left that one for Norensic, left that one for whoever, a couple more in a row. And all of these things, I'm doing startups. I'm bringing my skill set, but I am not joining it as a compiler writer. Then I did a bunch of stuff with types theory research and simple as a tutorial on how to write a compiler. These are again things where I'm not joining an existing compiler team. I'm writing a compiler in the style that I've written a compiler for forever and a day. Now I'm joining an existing large compiler group who has the other side of things that I've not looked at. So this is a new transition for me.
Yeah, I feel like many things that we're discussing this about LLVM, SSA, etc. Like ultimately, both approaches are trying to do equivalent things, just they're doing it slightly differently. But like, I think there are more similarities than it seems at first. It's like, okay, you can do it one way, you can do it another, just yet another design trade-off. Like
Maybe.
you lower things early on, you lower it later.
Maybe. I will say that, if I go count lines of code, it's like 1/10 to get the same job done with CF nodes, but same job may not actually be the same. Maybe that's the issue. It
Well,
looks like the same job's getting done at 1/10 the lines of code. Okay,
but again,
that's exciting.
you get, I don't know, code motion for free in your representation, but then you need to have the scheduling part, which is non-existent for the other approach.
You need to do this for doing what?
Need to do scheduling on the sea of nodes graph.
Instead of doing scheduling all along, which is what the other guys, I mean, I've done those classic compilers prior to Sea of Nodes, and you did scheduling all along. You just didn't call it that, but you definitely dealt with it every step of the way.
But yeah, I think my point, it's all equivalent at the end. You're trying to do the same thing. It's just you are choosing to do some things at different times.
Okay.
And yeah, there are trade-offs. You win something, you lose something.
And
Yeah,
I would say
that one I think I
even
win big on. There are places where I know I lose, but that's one I think I win big
I
on.
would even say that SSA CFG, like LLVM isn't really scheduling in a strong sense. Yes, those instructions appear to be in linear order in the basic blocks, but this order actually, when you go through the LLVM compilation pipeline and you go to the actual backend, which does instructional scheduling, it actually has like a dozen of heuristics. And you know what is the last one?
Schedule.
The least important one, program order. So it's only going to consider this program order that appeared in LLVM as the very last fallback heuristic. So that kind of shows that how unimportant it is, because at the end of the day, it's really the dependence between the operations that's gonna determine what are the
Right.
restrictions. And other than those dependence restrictions, you can reorder however you want. So maybe that's to the Arthur's point, that there's maybe more similarities than differences, because the schedule at the LLVM level, it's really still pretty loose. It's only really getting hard
It's
after you go
not.
through instruction scheduling.
It's not that we're going to have a different schedule in the end, or even a different tech once it gets down to time to claim I'm doing scheduling. I think we're going to be very similar there. It's the in-between phases where I'm going to ignore and not deal with, not see, not care, can't tell, can't care what the scheduling is while I'm doing other things. And that makes life a lot easier, or at least a lot less code involved, which I claim makes it look a lot easier.
I assume that the schedule in LLVM has some importance all along the way, because if you took a basic block and just reversed it, it would be wrong.
You have to maintain the dependencies.
Yeah, you have to maintain that dependency order.
Well, since you are maintaining,
Maybe. Right. No, then you got a good point. You're not honoring the dependencies. If you walk the block in block order, and you reverse the order, it would be a wrong order. You wouldn't be visiting them in a regional order. And there is no block in C2, well, in C2, to reverse. And you only can walk them in dependency order. Like it doesn't make, you don't have this option to walk them in this plenty guaranteed order. That's not given to you. You can't do it.
well, the same dependencies are there. They're just, instead of being explicitly encoded in the IR, they are derived from the IR using, I don't know, LS analysis, memory SSA,
Right.
other things.
I think memories are another one I win big on, but I also agree that I have a fixed kind of aliasing, which covers a broad set of generic Java, C++ programs, and doesn't do super well with doubly multi-dimensional nested loops. It's no better, it's no help in multi-dimensional nested loops. For other stuff, it helps really great. All right, I would love to have more of this, especially if I watch more LLVM videos or MLIR videos and get a more and more clue of what's trying to be accomplished there. But at some point, I'm going to have to, really be able to compare MLIR and CF nodes realistically next to each other.
There's
That,
also a
that's
bunch
coming.
of there's also a bunch of articles on archive. I can throw them your way at some point, or just remind me next week.
Yeah, I'll be drowned in how many videos I can watch and how rapidly I can ingest. But I guess keep them coming. The worst that can happen is I won't look.
And
But
there is
I am
also a
promising to look at
bunch
least some of them.
There is also a bunch of the MLIR open design meetings, and the ones I would call out in particular are the ones about attributes and operations. The reason I am calling them out, to me, they were very helpful because they talk about how are the low-level implementation details in MLIR working.
Yeah.
These are the talks by Mehdi Amini. And I think we are similar in this way that we like to understand things at the low level and how to build things from scratch. So that's those I would definitely recommend.
Yeah, like I said, throw them in. I'll get to them when I get to them, kind of thing. I have my hands full of videos to watch already, and there are several things on here I want to in our current links I'm going to look at too. But I'm going to call it pretty soon here. Anyone else want to ask anything?
So we have solved compilers.
We have what?
We have solved compilers. No more topics.
Compilers are simple. They just take data and
Yes.
output data.
They
It's
flip
just
it
a
around
big
and put it
function,
in.
pure
Yeah.
function, takes data in,
Are-
puts data out.
Aren't compilers just special case of databases? Or are
Um,
databases special case of compilers?
okay. They're all Turing complete. Is that what you're saying? Fine. Okay.
There's the
Well,
common joke about that.
um, I am going to call it quits and fun conversation. And maybe next week I'll have more to say about MLIR. I don't know. All right.
Right.
Bye-bye.